Hello friends, welcome to Susan and John MathTube. So we're going to learn how to solve the Legender's equation. Remember, sometimes they might ask you state Legender's equation and then solve. So it is always better that you by heart this equation. And sometimes what they do is they might put n equal to 1 or n equal to 2 and ask you to solve it. And remember, when you solve the particular Legender's equation, something different will happen than you expect. Normally, you'll be expecting the answer to be a naught times a series plus a1 times another series. But when you solve Legender's equation for, let's say, n equal to 1, n equal to 2, what happens is you will get a naught times series and then a1 times a polynomial. The series will be what you call, it will change into a polynomial. And sometimes what happens is you will get a naught times a polynomial plus a1 into series. Anyway, we start as usual. Let sigma am x power m be the solution. So I'm skipping all those steps. If you are not good with power series method, I'll strongly recommend to watch the power series method problems first. Anyway, we plug in everything into the equation, and I think you know what to do first. We have to distribute everything. So now look at this. I kept some things in red. You know very well why I do that, because you before equating the coefficients, you have to take these things inside, and it will become m, because you know a power m times a power n is a power m plus n, and this 2x should also be taken inside, so this 2 will be here and x will become m. You can try it yourself, yeah, and this n into n plus 1 should also be inside. Anyway, I don't have space for that. I will keep that in mind. Now I'm going to write equating coefficients of x to the power k on both sides. So you know the trick. M minus 2 is equal to k, so m should be k plus 2. I'll repeat again and again. Before watching this video, make sure the power series method is like in very good condition. And if you do not know power series method, please watch the last two videos in power series method, so that you get a very clear idea what's happening over here. So a k plus 2, k plus 2 times k plus 2 minus 1, and here it will be ak into k minus 1 minus 2 ak into k plus, don't forget n plus 1 comes inside, n plus 1 ak is equal to 0. So that's it. Now let's take everything to the other side. So k plus 1, k plus 2. Now when this goes to the other side, it will be positive. So ak times, and can you see ak is common? It's k squared minus k. And this will be plus 2k. And this will be minus n into n plus 1. So that will be minus n square minus n. That will be reduced into ak. This will be k squared plus k minus n squared minus n. Okay, almost ready. So ak plus 2, k plus 1, k plus 2 is equal to ak. So we have to combine this k squared minus n squared, that will be k minus n, k plus n plus k minus n. Now that k minus n comes common, so we get ak plus 2 is equal to ak times k minus n, then what will remain inside? K plus n plus 1, the whole divided by k plus 1 into k plus 2. Now if you want n minus, because normally we tend to write n minus 1, n minus 2, n minus 3 in the answer. So if you want that format, you can revert it. And I think you remember the connection between a minus b and b minus a. Think about it. What's the connection between 10 minus 6 and 6 minus 10? The answers will be negative of each other, right? Yeah. So if you want, you can write this like ak plus 2 is equal to minus, and this will be n plus k plus 1, because I want everything to be in the form n minus 1. I do not like 1 minus n. K plus 1, k plus 2. Now that's it. Now you will be able to handle it. So what do we do next? Yeah, we put k equal to 0. We put k is equal to 1. When you put k equal to 0, what will you get? a2 is equal to minus a0 n plus 1 divided by 1 into 2. When you put k equal to 1, we get a3 is equal to minus a1 n minus 1 n plus 3 divided by 3 factorial. And then you put k is equal to 2, so we get a3 is equal to minus a2 into n minus 2 n plus, this will be plus 2, this will be plus 2, and here it will be plus 3 divided by 3 times 4. Now I have to plug in this. So a3 is equal to a0 n n plus 1 n minus 2 n plus 3 by 4 factorial, and you put k is equal to 3. a4 will be eventually 3 plus 2, a5 will be eventually, there is a mistake, this will be a4, please correct it. Yeah, a5 will be eventually n minus 3 n minus 1 n plus 2 n plus 4 by 5 factorial into a1. So you can plug in all these things, and the pattern is like what you call, it goes like this. I'll show you the pattern. a0 times 1 minus, okay, the first term is n plus 1 by 2 factorial, and x squared will come, and then what happens is you can write these two terms n plus 1, and then move 2 units ahead and move 2 units backward. You can see those numbers here, and by 4 factorial x power 4. Now it will be minus, and then you write all these things, move 2 units to the front, that will be n plus 5 and n minus 4. And similarly a0 will also have the same logic. So try to complete it and practice, and I'll strongly recommend you try the Legendre's equation with n equal to 1, because they might ask like what you call the Legendre's equation by putting n equal to 1, n equal to 2, etc. Because when you solve, you will understand the answer will be completely different. For example, you can try to solve 1 minus x square into y double dash minus 2x y dash plus 1 into 1 plus 1, that will be 2y is equal to 0. You can try this, and when you solve, you will understand that one part will become a polynomial. Either the part with a0 or the part with a1 will become polynomial. And you know that that's called the Legendre's polynomial of first kind, second kind, etc., depending on the value of n. Okay, so that's it. I'll be back with other videos. So till then, my friends, bye.